In this problem, we're going to find the real solutions of the equation square root of the quantity 3x plus 1 minus the square root of the quantity x minus 1 equals 2. So the first thing that we want to do is we want to isolate whichever we think might be the ugliest square root. I choose this one as the ugliest one, the 3x minus 1. So we'll add the square root of x minus 1 to both sides. And that will give us the square root of 3x plus 1 equals 2 plus the square root of x minus 1. Cool. Now for the important step, we're going to square both sides. Okay, now here's the tricky part. When you square both sides, squaring the left-hand side isn't so bad. Squaring the right-hand side, we can only square the entire side at once. We unfortunately can't distribute squaring like we can multiplication. So we can't make this a 2 squared is 4 and the square root squared. We can only put one set of parentheses squared on the left and one set of parentheses squared on the right. So on the left side, this will be great because the square root and the square will cancel, just giving us 3x plus 1. On the right-hand side, unfortunately, we have to FOIL. So 2 plus the square root of x minus 1 times 2 plus the square root of x minus 1. Okay, so let's get into that. So 3x plus 1 equals 2 times 2 is 4. 2 times the square root of x minus 1. My puppy is playing with his squeaky toy, is 2 times the square root of x minus 1. Another x minus 1 times square root of x minus 1 times 2 is 2 times the square root of x minus 1. One nice thing at the end, square root x minus 1 times square root x minus 1, the square roots will cancel much like the 3x plus 1 squared and square rooted canceled. So this just gives us x minus 1. Okay, let's clean this up a little bit. 3x plus 1 equals, 4 minus 1 is 3. I'm going to take this x and put plus x in front. And then 2 square root x minus 1 plus another 1 gives us 4 of the square root x minus 1s. Okay, I'm moderately happy. We went from 2 square roots down to 1 square root, but certainly not all of our square roots are gone. We still have the square root x minus 1. So we're going to repeat these 2 steps here, isolating the square root that we still have and squaring both sides until all of the square roots go away. So subtract the 3 and the x, giving us 2x minus 2 equals 4 times the square root of x minus 1. Now at this point, you have a choice, and it's kind of up to you. You want to square both sides, definitely. You can divide both sides by 4. Sorry, I have to take a break to throw the squeaky toy. I would like to avoid getting fractions, dividing both sides by 4, because I see fractions happening over on the left-hand side. So as long as this number in front of the square root is being multiplied and not added or subtracted, it's perfectly reasonable to square both sides here, keeping the 4 there. So that would give us, if this is multiplied here, that would give us square the 4, because it's not in the square root, so that's a 16. The square root and the square cancel, x minus 1. On the left-hand side, we need to FOIL the 2x minus 2, much in the same way we did this 2 plus the square root of x minus 1 in the first couple steps. So we'll write 2x minus 2 times itself. And I'll do that fairly quickly with the squeaky toy in the background, giving us 4x squared minus 4x plus 4, and then distributing the 16 through 16 minus 16. So 4x squared minus 8x plus 4 equals 16x minus 16. Okay, so let me clean this up a little bit. Much better. Okay, now we can jump into step 3, which is solving for x. All right, so since we have an x squared with the 4x squared, my strategy for solving for x is going to be to get 0 on one side. I'm thinking factoring or maybe the quadratic formula. So we will subtract the 16x and add the 16. And when we do that, we've got 4x squared minus 24x plus 20 equals 0. I can definitely start factoring by taking out the 4 greatest common factors. So x squared minus 6x plus 5. Oh, thankfully that factors. So we have x minus 5 and x minus 1. Since the 4 doesn't have an x with it, it won't be part of our answer, but we have 2 potential answers, x equals 5 and x equals 1. Now here is a very important step. Once you get here, we could have accidentally given ourselves what we call extraneous solutions by squaring both sides. So unfortunately, we must check all of our answers. If there were a nice, quick way for checking answers, I would certainly share it with you. I don't know of one. And there's no pattern. It's, if one works, the other one doesn't. They could both work. They could, neither one could work. One could work, the other one can't. I mean, there's no real pattern to it. So unfortunately, we just need to check both of them. So I'll check the x equals 5 first. Let's see. Okay, so plugging that in, we have the square root of 3 times 5 plus 1 minus the square root of 5 minus 1, hopefully equals 2. So 15 plus 1 is 16. 5 minus 1 is 4. We'll see if this equals 2. Ooh, this looks good. Square root of 16 is 4. Square root of 4 is 2. Yep, 4 minus 2 is 2. So 5 is definitely a solution. Okay, let's check 1. 3 times 1 plus 1 minus the square root of 1 minus 1 hopefully equals 2. Okay, 3 times 1 is 3 plus 1 is 4. 1 minus 1 is 0. Ooh, this looks good. 2 minus 0 equals 2. Yes. So it looks like both of them work. So our answers are both x equals 5 and x equals 1.